Hello children, welcome to my channel. In this video I will teach triangles part 2. In part 1 I have already explained the basics of triangles. I have explained the different types of triangles, the angle sum property, the extrude angle property, then the concept of median, then the concept of altitude, angle bisector and perpendicular bisector. In this part I will move to congruency. This is a very important part. Okay, so let us move to congruency. Okay, first we will understand what is congruency. Remember, in congruency you have to see two things: shape and size. Shape and size. Okay, that means two objects, okay, any two objects are said to be congruent if they have the same shape and they have the same size. Okay, for example, see this these are suppose, see these yellow parts. Okay, all these yellow parts are have the same shape. Okay, they have the same shape and also they have the same size, so we can say that they are congruent. Okay, now look at these two chalks. Okay, look at these two chalks, they have the same shape and they have the same size, so again we can say that these two are congruent. Okay, if you look around you can see many things which are congruent. For example, if you see two ball lights, okay, two ball lights having the same shape and the same size, then we can say that they are congruent. Or two bulbs, suppose two 9-watt bulbs, okay, they are also congruent. Two fans of the same brand, same size, same shape, they are also congruent. So remember, two of these are said to be congruent if they have the same shape and the same size. Two things you have to remember. Okay, now we will move to triangles because we are in triangles. Okay, this concept congruency can be used in different figures. It can be used in triangles, it can be used in quadrilaterals, it can be used in pentagons and many other figures. It can also be used in solids. We can say that two footballs of the same size are congruent. Okay, or two cubes of the same size are congruent. Okay, so this concept congruency can be used in many objects. It can be used in plane figures, it can be used in three-dimensional solids. Okay, but we are in triangles, so we will be in triangles. Now, when are two triangles congruent? Obviously, if they have the same shape and the same size. Okay, remember, two triangles are said to be congruent if they have the same shape and the same size. And if two triangles are congruent, then if two triangles are congruent, then shape and size will be same. So what will happen? Corresponding angles will be equal because shape is same. Number 2, corresponding sides are also equal because size is same. These two things you have to remember. This is the basic. Okay, for any two objects which are congruent. For triangles, if two triangles are congruent, then the corresponding angles will be equal and the corresponding sides will be equal. Okay. Suppose I am taking two triangles. This is A, this is B, this is C. Okay. This is P, this is Q, this is R. Okay. Suppose these two triangles are congruent. Okay. Suppose it is given triangle ABC. This is the sign of congruency. See, this equal to sign tells us that side is same. Okay, this equal to sign tells us that side is same. This sign, okay, this sign tells us that shape is same. Okay, so triangle ABC congruent to triangle PQR. Suppose this is given. Okay, so from this, what can you get? The corresponding angles will be equal. So let us find the corresponding angles. Angle A will be equal to angle P. Means angle A will be equal to angle P. Angle B will be equal to angle Q. So angle B will be equal to angle Q. Angle C will be equal to angle R. So angle C will be equal to angle R. So we got the corresponding angles. Then we can get the sides. Okay. We can say AB is equal to PQ. Okay, AB is equal to PQ. Then we can say BC is equal to QR. So BC is equal to QR. Last one is AC is equal to PR. So AC is equal to PR. So from this you can understand that this will give us everything. Okay, this order will give us everything. If PQR is the correct order and the order is given QPR, then it is wrong. Okay, if PQR is the correct order, you cannot write it as QPR, it will be wrong. Okay, so here order is very important. Now let us move to different postulates using which we can prove congruency among between any two triangles. Okay. The first postulate is SSS. Okay, the first postulate is SSS. Means if three sides of a triangle are equal to three sides of another triangle. Okay, if three sides of a triangle are equal to three sides of another triangle, then the two triangles are congruent. Okay, remember this. If three sides of a triangle are equal to three sides of another triangle, then the two triangles are congruent. Let us understand this from a diagram by taking two triangles. Suppose this is A, this is B, this is C. Suppose this is P, this is Q, this is R. Okay, it is given that AB is equal to PR. Okay, and it is given that BC is equal to PQ, and it is given that AC is equal to QR. So you can see three sides of triangle ABC are equal to three sides of triangle PQR. So these two triangles will be congruent. Let us write it. So you have to write in this way: in triangle ABC and triangle PQR. From the beginning we don't know the order. Okay, order is very important. Okay, from the beginning you can write in any way you want: ABC, PQR, QRP, QPR, and in any order you can write. Okay, now let us write the sides. AB is equal to PR. AB is equal to PR. This is given. It was given. Okay. Then it is given BC is equal to PQ. This is also given. Okay. Last it is given AC is equal to Q1. So you can mark one thing. I have written triangle ABC on the left, and all the sides of triangle ABC I have written on the left. I have written triangle PQR on the right, and all the sides of triangle PQR I have written on the right. Okay, don't change the order. Don't write PQ is equal to PC. There will be confusion to find the order. Okay. So three sides of triangle ABC are equal to three sides of triangle PQR. So they will be congruent. So let us find the order. Okay. So triangle ABC congruent to, when you get this sign, order is very important. Okay. Here order is not equal, but here order is equal. Now see how to find the order. AB is equal to PR. That means these two sides are corresponding sides. So which will be the corresponding vertices? The opposite vertices. Now see in triangle ABC, the triangle I have erased. Okay, you don't need the triangle. Okay, once you get this, you don't need the triangle. Now in triangle ABC, which vertex is opposite to AB? Obviously C. Okay. In triangle PQR, which vertex is opposite to side PR? Obviously Q. So C and Q are corresponding vertices. So their position should be same. C is in last, Q should be in last. Ready? Next, BC is equal to PQ. Now which vertex is opposite to BC in triangle ABC? In ABC, the side opposite to BC is, the vertex opposite to BC is A. Okay? In triangle PQR, which vertex is opposite to PQ? Obviously R. Okay? So A corresponds to R. BC, PQ are corresponding sides. A and R are corresponding vertices or angles. So they will be in the same position. A is in first, as you can see. So R should be in first. Third one we don't need to find because R and Q over. So the last option is P. So this is the correct order. This is by Sss postulate. Okay. This is very important. This order is very important. Okay. Once you get the order, you will get everything. Now see, AB is equal to RP. See, AB is equal to RP. BC is equal to PQ. BC is equal to PQ. AC is equal to RQ. Okay, AC is equal to RQ. See, AC is equal to RQ. Correct. Now, which angles will be equal? Obviously, angle A will be equal to angle R. Once you get the order, you don't need anything else. You don't need the diagram, you don't need all this which you have written. Okay. So we can say now sides were already given. So I am simply writing the angles. Angle A is equal to angle R. Okay. Then angle B is equal to angle P. Angle B is equal to angle P. Okay. Last is angle C is equal to angle Q. First, second, third. This is the order in which you can find. This is called CPCT. CPCT means corresponding parts of congruent triangles. Okay, CPCT, corresponding parts of congruent triangles are congruent means equal. So they are equal. Okay. So this is Sss postulate. First postulate is one. Next is number 2 postulate is angle side angle. Okay, ASA, angle side angle. That means one side will be in between two angles. Okay, so the postulate is like this: if two angles and included side. Okay, just now I have to side should be in between two angles. So if two angles and included side, don't forget to mention included. Okay, included side of one triangle are equal to two angles and included, don't forget to mention included. Okay, included side of another triangle. Okay, then they are congruent. Okay, if two angles and included side of one triangle are equal to two angles and included side of another triangle, then the two triangles are congruent by this postulate ASA. Let us draw diagram. Let us take two triangles. Okay, suppose we have two triangles. Suppose this is A, B, C. This is P, Q, R. Okay, two angles and included side. Okay, suppose we will take any two angles. Suppose angle A and angle C. Okay, angle A and angle C of triangle ABC are equal to angle P and angle Q. Okay, angle A is equal to angle P, angle C is equal to angle Q. Then which side can you take? Only the included side, the middle one. Okay, you cannot take these two sides because it is Aas postulate. Angle side should be in between two angles. This side is equal to this side. Okay, so if this is the condition, if this is given, then we can say that these two triangles are congruent. So let us write this. In triangle ABC and triangle PQR. Okay, which angle? Angle A is equal to angle P. Angle A is equal to angle P. Given. Then side AC is equal to PQ. This is also given. Okay. Next, angle C is equal to angle Q. This is also given. Okay. So two angles and included side of triangle ABC are equal to two angles and included side of triangle PQR. So these two triangles are congruent. Let us find the order. When you give this symbol, order is very important. Okay, this is not the proper order. Here you can write randomly. Here order is very important. Now let us find the order. To find the order, you don't need to look at the triangle. There will be confusion. Now there will not be any confusion because they are separate two triangles. Sometimes triangles are mixed. Okay, when you go to the exercise, you will understand. If you look at the triangle and try to find the order, it will be more complicated. So it is better to look at all this. Okay. So ABC first, then PQR. See, angle A is equal to angle B. The previous postulate was side, side, side. Okay. When sides are given, it takes more time to find the order. But when angles are given, it is very easy. So directly you can say A is equal to P. Angle is equal to angle P. Angle and angle P are corresponding angles. A and P are corresponding vertices. So A first, then P first. Okay. Next, don't look at side. When you have angles, do not go for sides. Okay. From sides also you can find the order, but you don't need sides because you have angles. Then C is equal to Q. Okay. So angle C and angle Q are corresponding angles. C and Q are corresponding vertices. C third means Q third. So which will be in the middle? Obviously the last option, that is R. So this is A, S, A. Okay. A, S, A postulate. Once you get the order, you don't need to look at the triangle. You don't need to look at this. Okay. Everything will get from the order. So you can see angle A equal angle P. Check. Angle B equal angle R. It was not given, but they will be same. Okay. Angle C equal angle Q. It was given. Then AB is equal to PR. Not given, but they will be same. AB will be equal to PR. BC is equal to RQ. Okay. BC is equal to RQ. It was not given, but you will get it. Okay. BC will be equal to RQ. Last one is AC is equal to PQ, which was given. So this order is very important. Remember that. Again and again I am telling this. Once you get the order, you got everything. Okay. So the order is the key to solving everything. Okay. So this is Aas postulate. Now let us move to SAS. The third postulate is SAS. It is similar to ASA. In ASA postulate, side is in between two angles. In SAS, angle is in between two sides. Okay, it is similar to ASA. So here we can write, if two sides and included angle of one triangle are equal to, okay, the two sides and included angle. Do not forget to mention the word included. Okay, of one side triangle are equal to two sides and included angle of another triangle. Okay, then the two triangles are congruent. Okay, so this is the postulate SAS. Now let us see this diagrammatically. Okay, let us draw two triangles and get what is SS. Now we are in SAS postulate, side angle side. Okay, let us draw two triangles. A, B, C. Okay. P, Q, R. Two sides and included angle. Okay. You can take any two sides. Suppose AB is equal to PR. Okay. Then suppose BC is equal to QR. We have taken two sides. Then which angle can you take? There are three angles, but we can take only the included angle, the angle between the two sides. So we are bound to take this angle and this angle. You cannot take any other angle. Okay. So SAS. Okay. So these two triangles are congruent. Let us write this. In triangle ABC and triangle PQR. Okay. Let us start from side angle side. So AB is equal to PR. This was given. Then angle angle B is equal to angle R. This is also given. Okay, last is side BC is equal to QR. This is also given. So two sides and included angle of triangle ABC are equal to two sides and included angle of triangle PQR. So these two triangles are congruent. Let us find the order. Okay. To find order, always target angles because it gives you the order faster than the sides. Okay. So when you have angles, don't go for sides. When you don't have angles, then go for sides. Okay. See, we have angles. Angle P and angle R are corresponding angles. So definitely B and R will be corresponding vertices. So B is in the middle. R should be in the middle. Okay. Angle over. Now we don't have any other angle, so we are bound to move to sides. Now move to sides. ABPR. Don't look at the triangle. There will be confusion. Okay. Simply look at these two. ABC, PQR. From here you will get everything. You don't need to look at the triangles. AB, PR are corresponding sides. So their opposite vertices will be corresponding vertices. Which vertex is opposite to AB? C. Which vertex is opposite to PR? Q. So C and Q are corresponding vertices. C is in third. Obviously, Q will be in third. So what is the last option? Last vertex? That is P. This is called Sss Postulate. Okay? Sss Postulate. Then once you get the order, you get everything from the order. You don't need to look back. Angle A is equal to angle P. Angle B is equal to angle R. Angle C is equal to angle Q. Okay? Then AB is equal to PR. Okay? BC is equal to RQ. Last is SC is equal to P. You will get everything from the order. Okay? So this is Sas postulate, the third postulate. Now let us move to the fourth postulate. Okay. The fourth postulate is angle side. Okay. Angle side means two angle and one side. If two angles and one side. Now do not take the included side. If you take the included side, it will become ASA. Okay, already you have done ASA. So don't take included side. You take any other two sides. So if two angles are in one side of one triangle are equal to two angles and corresponding. Okay, here you cannot write one side. Okay, why it is corresponding I will explain later on. Okay, if two angles and one side of one triangle are equal to two angles and corresponding side of another triangle, then the two triangles are congruent by Aas postulate. Okay, so let us move to triangles. Let us draw two triangles and understand this. Suppose these are two triangles. Two angles of this triangle are equal to two angles of this triangle. So let us take any two angles. Suppose angle A is equal to angle R. Okay. Then angle C is equal to angle P. Okay. Two angles of triangle two angles of triangle ABC are equal to two angles of triangle PQR, and we have to take one more side. Okay. We cannot take AC because it is the included side. If you take AC, it will be Aas postulate, but we want Aas postulate. So you are free to choose either AB or BC. So let us take BC. Let us take BC. Here, what was the postulate? If two angles and one side of one triangle are equal to two angles and corresponding side. Okay, corresponding side means. Okay, so see this BC I have taken. This is opposite to angle A. Okay, the side BC which I have taken, it is opposite to angle A. Now angle A is equal to which angle here? Angle R. Its opposite side is QP. So I have to take QP only. Okay, A is equal to R. So opposite sides means BC and PQ only we can take. Here I cannot take QR. Okay, here I cannot take QR. Also I cannot take PR. If I take PR, it will be ASA. Cancel this. I cannot take QR also because it is opposite to P, which is not equal to A. So A is equal to R, then BC is equal to P. Here, suppose we would have taken AB. Okay, if we would have taken AB, then we would have taken QR, because AB and QR will be corresponding sides. AB and PQ will not be corresponding sides. Okay, so this is the order in which you have to take. Now see AAS, AAS. These two triangles are congruent. So let us write this in triangle ABC and triangle PQR. Okay, angle A is equal to angle R. This is given. Then angle C is equal to angle P. This is also given. Last is side. BC is equal to PQ. This is also given. Okay. Now let us find the order. Triangle ABC is congruent. Now let us find the order. Okay, randomly you cannot write. Here randomly you can write, but here you cannot write randomly. When you have angles, don't move to sides. Okay, A is equal to R. A first, so R first. C is equal to P. C last, so P last. So which is the last option? Obviously Q. This is AAS. Angle side postulate. Then once you get the order, you don't need to look at all this. Everything you get from here. Angle A is equal to angle R, angle B is equal to angle Q, angle C is equal to angle P, then AB is equal to RQ, BC is equal to QP or PQ, same thing. Last is AC is equal to RP. Okay, so order that will give you everything. So this was the fourth postulate, AAS. Then the last postulate, so out of the four postulates, first one is SSS, second one is ASA, okay, third one is SAS, fourth one is AAS. So ASA and AAS. Here also two angles one side, here also two angles one side. So you can say this one. It is special case of AAS postulate. Okay, angle side angle is a special case of AAS postulate. The last postulate is RHS. Okay, this is the last postulate, number 5. RHS means right angle hypotenuse side. Right angle hypotenuse side. Okay, that means from this we can understand that this postulate is related to right triangle only. Okay, the previous four postulates, they can be used in any type of triangle: acute angle, obtuse angle, right triangle, scalene triangle, isosceles triangle, equilateral triangle. They can be used in any type of triangle, but this is used only for right triangle. Okay, so first let us understand. First let us take right triangle. Suppose this is a right triangle ABC in which angle B is 90 degree. Okay, so angle B is 90 degree. The side opposite to B, okay, the side opposite to the right angle, means here AC, is called hypotenuse. Okay, remember this, the side opposite to the right angle of a right triangle is called hypotenuse. The remaining two are called legs. Okay, the side opposite to right angle is called hypotenuse. The remaining two sides, or the two sides containing the right angle, are called legs of the triangle. Okay, here hypotenuse is more important. These two legs are not important. So let us take two right triangles. Since I have a very small board, so I am raising again and again. Okay. A, B, C. Here B is 90 degree. P, Q, R. Here Q is 90 degree. Okay. So 90, 90. Rectangle over, then hypotenuse we have to take. Okay. Suppose AC is equal to PR. Right angle over 90, 90. Hypotenuse over AC is equal to PR. Then we have to take one more side. Suppose we will take BC of triangle ABC, and it is equal to, we can take either QR or you can take PQ. It is your wish. Okay. Suppose PQ. Right angle, hypotenuse, hypotenuse, side, side. These two triangles are congruent. So let us write this. In triangle ABC and triangle PQR. Okay. First right angle. Angle B is equal to angle Q. This is given. After right angle, move to hypotenuse. This is the hypotenuse AC and PR. This is also given. Now move to side. Okay. DC is equal to PQ. Okay. So these three things are given. Now we can find the order. I told that when you have angle, don't move to side. Since we have angle, first move to angle. B is equal to Q. So B middle means obviously Q will be in middle. Now move to side. We don't have angle. AC is equal to PR. That means AC PR are corresponding sides. Do not look at the triangle. Okay? It will create confusion. We don't need the triangle now. AC is equal to PR. These two are corresponding sides. So the opposite vertices will be corresponding vertices. So which are the opposite vertices? Opposite of AC is B. Opposite of PR is Q. So B corresponds to Q. That is already written. Okay. That is already written. Okay. So this did not help us. Let us move to this one. BC and PQ are corresponding sides. So the opposite vertices will be corresponding vertices. Let us take the opposite vertices. Opposite of BC is A. Opposite of PQ is R. So A corresponds to R. A first, so R first. The last option is P. This is called RHS. Okay. Now once you get the order, you get everything. You don't need even this. You don't need the diagram. You don't need the writings. Okay. You will get everything from here. Angle A is equal to angle R. Angle B is equal to angle Q. Angle C is equal to angle P. Okay. AB is equal to RQ. BC is equal to QP. AC is equal to O. Okay. So these are the 5 postulates. Okay. These are very important. First one is Sss postulate, means side, side, side. Okay. If 3 sides of one triangle are equal to 3 sides of another triangle, then the 2 triangles are congruent. Next is ASA, angle side angle. Okay. Means if 2 angles and included side of one triangle are equal to 2 angles and included side of another triangle, then the 2 triangles are congruent. Next is SAS, side angle side. If 2 sides and included angle of one triangle are equal to 2 sides and included angle of another triangle, then the 2 triangles are congruent. Do not forget to use the word included. Next is AAS, angle side. Means if 2 angles and one side, not included. Okay. If 2 angles and one side of one triangle are equal to 2 angles and corresponding side. Okay, don't say one side, say corresponding side of another triangle, then the 2 triangles are congruent. The last postulate is RHS, right angle hypotenuse side. Okay, and see hypotenuse and side. Okay, if hypotenuse and side of a right triangle. Okay, you don't need to mention right angle, because if you mention right triangle means obviously one angle will be 90 degrees. So you don't need to mention right angle. Simply mention hypotenuse and side. So if hypotenuse and side of one right triangle are equal to hypotenuse and side of another right triangle, then the 2 triangles are congruent. So these are the 5 postulates, basing on which, using which we will be proving congruency and we will be getting the results. Okay. So let us take some examples. Okay. So for the first example, it is a property of triangles also. Okay. It can be applied in every triangle. The incenter of a triangle is equidistant from all the sides. Prove it. Okay. The incenter of a triangle, okay, is equidistant from all the sides. Prove it. This is a property of every triangle. Remember this. Incenter of any type of triangle will always be equidistant from all the 3 sides of the triangle. Now let us prove this using congruence. Okay. I hope you are able to recollect what is incenter. Incenter is the point of intersection of angle bisectors of a triangle. In first part I have explained what is angle bisector and also incenter. The 3 angle bisectors of a triangle are concurrent. They intersect at a point which is called incenter, represented by the capital letter I. I have told you part 1. Okay, so let us draw a triangle. A, B, C. Triangle ABC. Let us draw angle bisectors. Okay, then only we will get the incenter. bisected angle A. We have bisected angle B. Okay. Now, if you bisect angle C, it will pass through this point. Okay. My diagram is not accurate. Okay. So this angle is equal to this angle. Okay. I have drawn three bisectors. They will intersect at a point. Suppose I. This point is called incenter. And now we have to prove that this incenter is equidistant from all the three sides. Now in mathematics, distance means perpendicular distance. That means from I, we have to draw perpendicular on all the three sides. Okay. Right. Given. Okay. So this is the process in which you have to write. First, given. What is given? I is the incenter. Incenter means it is the point of intersection of angle bisectors. Okay. Then to prove okay, incenter or I is equidistant from AB, BC and AC. Okay. I is equidistant from AB, BC and AC. Okay, this we have to prove. Now construction. Now we need construction. Okay. Construction. So to draw perpendicular. Okay. Draw IP perpendicular to AB. Okay. Draw IP perpendicular to AB. So you can see I have drawn perpendicular, IP perpendicular to AB. Then IQ perpendicular to BC. IQ perpendicular to BC. Okay. Then IR perpendicular to AC. Okay. IR perpendicular to AC. So construction is over. Now we'll go to proof. Slowly we will prove that all these IP, IQ and IR are equal. Okay. We will prove that IP is equal to IQ is equal to IR. This is our target. Okay. I am writing the target here. IP is equal to IQ is equal to. This is our target. Okay. Slowly we will prove. Directly we cannot prove that 3 are equal. We have to prove 2 are equal. Suppose I will prove that IP is equal to IQ. IP is equal to IQ. For that, I have to take these two triangles. Okay, means triangle BIP and triangle BIQ. Okay, these two triangles I have to take. So let us go for proof. In triangle BIP and triangle BIQ. Okay, we will take these two triangles. Ready? In these two triangles, we will try to prove congruency. Okay. See 90, 90 means we got one angle. Okay. this angle is equal to this angle. This was also given. So we got two angles. Okay. Next is this side BI is common. So AAS, angle side. We can take this postulate, angle side. So angle BPI is equal to angle BQI. BPI is equal to BQI. Why? Each 90 degree. Okay, this is the reason. Always you have to write the reason. This is the statement. This is the reason. Okay, you have to write statement then reason. Without reason, your statement is useless. Okay. One angle we got, then angle IBP is equal to angle IBQ. This angle is equal to this angle. Okay, because BI bisects angle B. Okay, we got two angles, then we take side. BI is equal to BI because they are common. Okay, so angle side. Now let us find the order. Okay, don't look at the triangle, there will be confusion. Okay, simply look at here. Angle P, angle Q. BPI means target P. Okay, look at the middle vertex. P is equal to Q. Okay, P is equal to Q. P third, so Q third. B is equal to B. Okay, B first, so B first. B and B. Okay, so the last option will be I. First and third over, B and Q over. Last option is I. This is Aas postulate. Okay, but see, this is the right triangle, but we have used Aas postulate. So just by looking at a right triangle, do not think that only RHS postulate will be applicable. Okay, I told side, angle, side, angle, and side, angle, side. These four postulates can be used in any type of triangle. Okay. So although it is a right triangle, but we have used Aas postulate. Okay. So by this postulate, these two triangles are congruent. After this, we don't need this. So from this we can get IP is equal to IQ. This is our target. Okay, we got IP is equal to IQ. CP corresponding parts of congruent triangles. Okay, let it be equation 1. We will need it later. For that reason I have given equation 1. I will be erasing this, but you have to write this. IP is equal to IQ. Okay, suppose here I am writing IP is equal to IQ. This is equation 1. Okay. Our target was to prove IP is equal to IQ is equal to IR. IP IQ over. Next target is IR. Okay. So now we can target IQ and IR or IP and IR. That depends on you. Okay. You can prove that IQ is equal to IR, or you can prove that IP is equal to IR. Both will do the work. Suppose let us prove IQ is equal to IR. You have to take these two triangles. Okay. In triangle IQC and triangle IRC. Okay, in triangle IQC this triangle and triangle IRC this triangle. Okay, again the same postulate. See, 90 90 angle angle. Okay, two angles IC is common, so angle angle side postulate. Okay, angle IQC is equal to angle IRC by each 90 degree. Okay, see, 90 90. Then angle ICQ equal angle ICR. Why? Because IC bisects angle C. Okay, IC bisects angle C. How do you get the incenter? By doing angle bisectors only. Okay, so IC bisects angle C. This is the reason. Next is IC is equal to IC. This is common. Okay, IC equal IC. This is common. You can see IC is common. So now we can get the order. Triangle ICQ. First one you can take in any order. IQC, ICQ, QCI, CIQ, in any order you can take. Okay. The second depends on the first. Now let us get the order. You don't need to look at the triangle. Simply look at here. When you have angles, don't go for sides. Q, R. Angle IQC, angle IRC. So Q corresponds to R. Q third, R third. Then C, C, ICQ, ICR, angle. C, C, C middle, C middle. What is the last option? I. So I. ICQ, ICR. This is angle angle side postulate. After getting the order, you don't need all this. Don't need the triangle also. Okay. Our next target was IQ and IR. See, IQ, IR. Okay. So we can write IQ is equal to IR. Simplicity equation 2. Okay. IP equal IQ simplicity equation 1. IQ equal IR simplicity equation 2. Okay. Now we can write from equation 1 and 2 we get, we combine equation 1 and 2, IP equal IQ and IQ equal IR. So all three are equal. We get IP is equal to IQ is equal to IR. Okay, that means so I is equidistant from all the sides, hence proved. Okay. So hence we proved that the incenter of a triangle is always equidistant from all the three sides. The triangle may be of any type. Okay. We proved this using congruency. Okay. Now let us take another example, which is also a property. Actually, first I am giving the properties, important properties. This you should remember, these are very important. Okay. In the first part, whatever I told, they are very important. You have to remember. In the second part, till now what I have told, they are also very important. Okay. Don't think that these are examples. These are actually properties of a triangle. Okay. Examples are not that important. You may remember, you may forget, no problem. But these properties are very important. Okay. Next property is circumcenter of a triangle is equidistant from all the vertices prove it. In first part I have given the concept of circumcenter. The point of intersection of perpendicular bisectors is called circumcenter, and remember it is equidistant from all the three vertices of the triangle. Let us prove it. Okay. How to get circumcenter? By drawing perpendicular bisectors. Okay. Suppose this is equal to this. Suppose L1 is the perpendicular bisector of BC. Suppose this is Q. Let us name it L2. Sorry, L2. Let us take the midpoint of AB. Suppose this is P. The midpoint of AB is P. Okay. Through P, let us draw a perpendicular which will become the perpendicular bisector. Suppose this is line L1. L1 is the perpendicular bisector of AB. L2 is the perpendicular bisector of BC. Okay. Now, if you draw the perpendicular bisector of AC, it will definitely pass through this point, because perpendicular bisectors are always concurrent, means pass through the same point. Okay. Okay. L1 is the perpendicular bisector of AB, L2 is the perpendicular bisector of BC, L3 is the perpendicular bisector of AC. They are intersecting each other at a single point, which is the circumcenter. Let us name this O. O is the circumcenter. We have to prove that this point O is equidistant from A, B and C. That means AO is equal to BO is equal to CO. Okay. AO is equal to BO is equal to CO. This we have to prove. Let us start. Given O is the circumcenter, means it is the point of intersection of the three perpendicular bisectors which are L1, L2 and L3. This is given. To prove OA is equal to OB is equal to OC, means O is equidistant from all the three vertices. This you have to prove. This is our target. Okay. We don't need any construction here. Let us go to proof. Okay. Our first target are OA and OB. Okay. So if you want to prove equality between OA and OB, you have to take these two triangles, OPA and OPB. Okay. In triangle OPA and triangle OPB, okay, let us see how we can prove congruency. You can see OP side is common, 90-90. Okay, 90-90. Then PA is equal to PB. This is given. So side angle side, SAS. Okay, so you start from side. OP is equal to OP. This is common. Okay, angle OPA is equal to angle OPB is 90 degree because L1 is perpendicular bisect to perpendicular. Okay, then AP is equal to BP. We can say this is given. Circumcenter given means the perpendicular bisector is given. Okay, because how to get the circumcenter? Only by drawing perpendicular bisector. There is no other option. Okay, so these are given. Now let us find the order. Suppose I am writing AOP. First one you can take in any order as you wish. Here I have written OPA. Here I have written AOP. You can take any order if you want as you wish. Okay. Now let us target angle. Angle OPA is equal to angle OPB means P last, P last. We don't have any other angle, so we are bound to target side. Don't look at the triangle. Okay, there will be confusion. OP and OP are corresponding sides, so the opposite vertices will be corresponding vertices. With what are the opposite vertices? Opposite of OP is A. Opposite of B is B. So A corresponds to B. A first, B first. So the last option is O. This is Sss postulate. Okay, Sss postulate. From this we can get AO is equal to BO. First part we got. Okay, AO is equal to BO. CP equation 1. Okay. Okay. AO is equal to BO over. Our last part is OC or CO. So you can prove AO is equal to CO, or you can prove BO is equal to CO as you wish. Okay. Suppose we will prove BO is equal to CO. To prove BO is equal to CO, you have to take this triangle BOQ and this triangle COQ. Okay, try to see the triangles. Okay, BOQ and COQ. I am not proving, it will be proved in the same postulate. OQ is common as you can see, 90-90, then BQ is equal to CQ. So again by SAS postulate, the two triangles can be proved to be congruent. Okay, so I am not proving this. You can prove this. So triangle BOQ is congruent to, let us find the order. In triangle BOQ, Q is 90. In triangle COQ, again Q is 90. So Q corresponds to Q. First look at angle. Q corresponds to Q. Q third, Q third. We don't have any other angle. We have to take now sides. Okay. You can see OQ side is common. Here I am looking at the triangle because I am not written. If you write, you don't need to go for the triangle. From that writing, you will get everything. Okay. Since I have not written, so I am looking at the triangle. Okay. So OQ is equal to OQ. The opposite vertices will be corresponding vertices. What are the opposite vertices? Opposite of OQ is B. Opposite of OQ is C. B corresponds to C. BC. Okay. B first, C first. So the last option is obviously O. Okay. BOQ congruent to COQ. This is by SAS postulate. Once you get the order, you don't need this triangle. We wanted BOCO, we got BOCO. Okay. BO is equal to CO, CP equation 2. Okay. So now we can write From equation 1 and 2, we get AO is equal to BO is equal to CO. Okay, see, from equation 1 and 2 we are getting this. So, O means circumcenter. Is equidistant from all the vertices. Okay, so the circumcenter of any triangle is always equidistant from all the three vertices of the triangle, hence proved. Okay, so this became a very long video. This is geometry, so it will be time taking. I hope you have understood the postulates, you have understood what is congruency. Simply two things are important. Congruency means shape and size. Okay, shape and size. Angles will be equal, sides will be equal. Okay, there are 5 postulates. Okay, I have explained what are the 5 postulates and 2 examples I have given in the third part and the last part. Third part is the last part. In that part, I will explain some more examples. Okay, so I hope you have understood. Thank you for watching.